Good
Good
morning.
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 Let us introduce ourselves. My name is Abi Fadan Altair.
My name is Kedrick Samuel Frumentius.
My name is Nova Ramadan Kifana.
My name is Rayhan Akbar Kelaya.
My name is Artari Yutina.
And we are from Group
Group
1.
1.
We are proudly present our presentation about ultra-compact electric foldable scooter. So on the first page, we're going to talk about project background design brief. And the second one, background study and needs.
And we are going to talk about product design specification in page 3. And we are going to move on to design function decomposition and analysis.
Next, we will explain about the morphological chart function and solution. Later, concept development screening matrix.
In 7 page, final concept selection scoring matrix. In next page is final design.
And lastly, we're going to finalize our presentation with our conclusion.
So in our project background, we separate four main important things. The first one is UTM, environmental sustainability, a program where students engage in sustainability, interacting and experiencing a healthy lifestyle. And we support the e-scooter campus program. So coordinates this campus sustainability programs and achieve initiative regarding alternative transportation for energy saving futures. So the third one, 70% of human being want new transportation option. So electric scooter may be the chosen one. And the fourth one, parking problems. So in recent years, more and more university employees and students tend to choose their residence in place inside the campus. As a result of this change, the number of private cars and bikes owned by them is increasing rapidly. So next, in our background and study needs, one of the main problems which the humanity is facing in the actuality is the climate change. It is well known that the pollution and carbon dioxide produced by humans is speeding up the climate change. The main cause of it is the carbon dioxide emitted by transport with a total of 31% in the world. Nowadays, the entire world population has become used to travel longer distance than ever before, especially for the college students with high level of mobility. They have to travel from places to places on certain amount of time. These trips are incorporated in college students' life and there is nothing to do in order to try to reduce their amount. Therefore, the only possible way to reduce the carbon emissions to the environment is introduce new clean modes of transportation. For this reason, this thesis is based in the introduction of one of the most modern introduction to the electric transport, electric scooters. So in our problem statement, the first one is the electric scooter was chosen in this engineering design project. The initial problem for designing this project is to design the product that is not similar to the current market. The second one, design a solution to tackle the existing pollution problem with a lithium-ion power scooter. The third one, existing vehicle having so many problems towards the environment. The fourth one, replacing them with more efficient and durable electric vehicle could be a possible alternative. The last one, this will be achieved by designing a compact, portable, easy to use. So in our design brief, we believe that a compact foldable electric scooter which is user friendly for university students commuting their class within the safety standards. The scooter should be lightweight so it can be carried up the stairs when folded. At the same time, it could carry heavy weight within the weight limitation. The folding mechanism of the scooter should be easy so that can be parked or stored anywhere fairly easy. It the long-lasting battery that the electric scooter use conveniently lessen the required number of charging so that it can be used for long session of commuting. Since the scooter is a battery-powered transportation device, it marked as an eco-friendly product as it drastically reduces the noise and air pollution that generic transportation produces.
Okay, thank you, Abifadan, for the explanation. And now we're going to proceed to product design specification. In this part, I'm going to show you the safety procedure of our project because safety is our number one priority. First of all, we have to wear a safety approved helmet that fits properly. A properly fitted helmet should touch all the way around your head. And then you should wear elbow and knee pads to save yourself from cuts, bumps, and bruises in case of a fall. And also you have to scoot only in daylight for best visibility and avoid scooting in the rain. You also should stay on the sidewalk when riding to avoid wet or broken sidewalks. And you always have to stop at street corners, looking both ways and walk your scooter across the street. To stop quickly, step off your scooter while still holding handlebar. If you don't feel safe easily stepping off the scooter, you are going too fast and need to slow your speed. And now we're going to move on to the materials. The body parts are made of aluminum alloy, plastic, and rubber to provide safety while riding. The electric motor are made of metal copper wires and magnets to convert electricity to kinetic energy. And last, battery. The batteries are made of various metals and minerals to provide electricity. And then for the ergonomics, the suspension had good quality to guarantee comfortable, adjustable handle, and can be folded, soft grip bar, and high quality of grip tape for foothold. And for the performance, this ultra-compact electric foldable scooter is famous for thrilling performance, safety features, and affordable price for college students. The result? An incredibly well-rounded, easy to live with, everyday, fast, and durable scooter. The following below are the performance details of the scooter. The speed, the horsepower of the scooter is 450 watts, the maximum speed is 25 km per hour, and the maximum mileage is 15 until 25 km. For the power, voltage battery is 24 volt and 6.6 amp hour. For the charging is 100 until 240 volts or 50 to 60 hertz, and the rated power is 250 watts. The agility of the scooter for the maximum climbing is 15 until 20 degree, and also this device can be operated by using foot pedal.
Okay, thank you for your explanation, Kedrick. Now, about the weight and dimension. The person maximum weight is 100 kilogram. The dimension is 92 multiplied by 41 multiply 100 centimeter, and the tire size is 5 inch. And then the scooter weight is 12 kilogram, and the battery able to last up to 5 years. Minimal effort of repairing on road usage only. Next, of course, the ecology we support the go green. Next, and then aesthetic underglow scooter LED RGB, and the headlight is LED. For the paint, we only have two model, carbon black and silver dove. Next, the minimal maintenance scooter cover indoor or outdoor, UV and water resistant, and also dust proof.
Okay, thank you, Raihan. And now I'm going to explain the design function decomposition analysis. It is divided into three components. And the first one is electric component. It includes speed controller. It controls the speed. Power switch turns on and off the scooter. Motor revolves the wheel providing acceleration. Swappable battery which supply to the scooter. Headlight and brake light. Visibility for the rider and other people. And the second component is handling component. It includes hand grip, which gives a better grip for the handlebar. Brake lever activates the braking system. Handlebar, which controls the direction of the scooter. Wheels, it moves and gives traction to the scooter. Lastly, the brake caliper, which slows down the scooter. And last component is our frame. It includes front fork, which holds the wheels in place with the frame. The stem, it connects the handlebar and deck plate. The deck plate is a standing spot for the rider. Lastly, the kickstand. It allows the scooter to be kept upright without leaning against another object.
And next, morphological function and solution. As shown here, we have 5 solutions and the materials. For the frame material, we have 5 options, and they are carbon fiber, aluminum, alloy, stainless steel, and mahogany. For the tires type, we have slick, off-road, solid, all-season tire, and honeycomb. For the battery position, we have 5 option for positions, and they are outside stem, on the foothold, inside stem, in the foothold, and in the handlebar. For the headlight, we choose LED as the type of the lamp, and we have 4 options for the positions, and they are near front tire, LED at the handlebar, upper neck LED, and LED on the stem. For the handle grip, we have 5 options, and they are rubber hand grip, leather hand grip, foam, rubber grip with spike, and carbon grip. For foldability, we have 4 options, and they are vertical foldability, simple foldability, complex foldability, and lastly, triangle foldability. And here I will explain about our screening matrix. We have 15 concepts here, and we have several criteria as our point to screening our concept. From this screening, we have the best 3 of the option from our design. Next. And here, in as the picture shown below, the best of 3 of our concepts. Okay. From the best 3 of our concept, here we suggest to manage create the new concept that we consider as the better design as we have. And they are carbon fiber racing electric foldable scooter, ultra compact electric foldable scooter, adaptive electric foldable scooter, multitasking electric foldable scooter, and casual electric foldable scooter. And for the scoring matrix, we have SEMS criteria, and from the best 3 previous that we previous presented, the newest design has better performance, and the best one is ultra compact electric foldable scooter that we choose as the latest of our design, and we will explain it in the next page.
And now I'm going to explain about our final design and what's new in our design. Here are the in-depth analysis of our final design, which is ultra compact electric foldable scooter. It includes a headlight, an aluminum alloy body frame, a reflector at the bottom, and we choose a solid wheel as our tire types. For the handlebar, we option the rubber grip handlebar, and we added a speedometer. We also don't forget a manual rear fender, which we can step on in case of emergency braking. We also add a brake light for our safety. And lastly, we added a kickstand on our scooter design so we can hold our scooter upright without leaning it against another object. So what's new on our final design? As I mentioned, we added a speedometer. This speedometer has a built-in ambient sensor that can change the speedometer light at night. And for the throttle system, we use a throttle controlled by pressing thumb. It has two thumb control, which is thumb throttle and thumb brake. We also include an innovative design of regenerative braking. So when braking, it charges battery by using electric motors as a generator. Lastly, we added a hook so the scooter can hang our bag. So in conclusion, based on our presentation about the design of electric foldable scooter, we choose the ultra compact electric foldable scooter as our final design thanks to its advantages. We're positive that many people will choose our product as the next generation electric scooter, as it able to fulfill humans' needs to gain more productivity and mobility. Our final design meets criteria of our design brief, which are lightweight, can be parked or stored anywhere easily, long-lasting battery, able to carry heavy weights, and eco-friendly.
I think that's all for our presentation. We hope you are satisfied, and if there are any mistake, please forgive us, and thank you.
Thank you.
Thank
Thank
you.
you.
Thank
Have a nice
you.
day.
Have a nice day.